Polynomial plays very important role in general mathematics and especially in SAT 2, Mathematics 2 also, because various questions are based on the polynomial only, that concept only. Now, what is a polynomial? A general polynomial is represented by an x to the power n plus an minus 1 x to the power n minus 1 and so on and so forth, a naught. Here, this an should not be equal to 0. Then the degree of the polynomial is n. Now, the next question is how to find a relationship between the roots of a polynomial and the coefficients, which I have represented by a naught, a1, a2 and an. Now, let's take a particular example or a polynomial of degree 3 only. So, let's take a3x cube plus a2x square plus a1x plus a naught as a polynomial of degree 3. Now, what is the relationship of these coefficients and the roots of this polynomial or the zeros of this polynomial? Let's take these roots as alpha, beta, gamma. Now, the important relationship between the roots and the coefficient is something like this, that the sum of all the 3 roots, that is alpha plus beta plus gamma, will be equal to minus a2 divided by a3, right? Now, here alpha, beta, gamma may be real roots also, maybe complex roots also, and maybe one or alpha and beta may be equal also. Whatever that relationship is, the sum of all the 3 roots will be equal to negative a2 divided by a3. Now, if I take product of roots 2 at a time and add, that is alpha beta plus beta gamma plus alpha gamma, then this will be equal to a1 by a3. Now, you can see that first I have taken negative and then positive. So, it's alternatively negative, positive, negative. And the last one is that product of all the 3 roots, taking all the 3 at a time, that is alpha into beta into gamma, that will be equal to a naught by a3. And that sign will be negative. Sign will be negative because first is negative, then positive, then negative. So, there's a relationship between the roots and the coefficients of the polynomial. And that relation, with the help of this relationship, we can find various, we can in fact, with the help of roots, we can find the polynomial also. And with the help of polynomial, we can find the roots also. That is, if you have a higher degree polynomial. That's the first part. The second part is the rational root theorem, which is again an important part of the polynomials. Rational root theorem, in fact, suggests you how many rational roots may be there for a particular polynomial. As you already know, for a second degree polynomial, you can always find the roots by various methods. The moment you move further and take the polynomials of higher degree, then it's very difficult. At least, as far as rational roots are concerned, we can at least guess that these are the roots and we can find out which one will fit in the particular polynomial. So, let's understand what is the rational root theorem. See, in this case, you have to take the coefficient of highest degree power of x and constant. Now, the rational roots, which are, possible rational roots are, all the factors of a naught divided by each factor of a3. That will give you idea of total number of rational roots, of course, with a positive sign and a negative sign also. Let's take a very important question here, that suppose you have 2x cube plus 5x square plus maybe 9x and plus 3. Now, I want to guess about the rational roots. I mean the roots, if there is a rational root of this particular polynomial, what are the possibilities? So, what you do is, first you find out the factors of 2. That is the numbers which are dividing 2. So, these numbers are only 1 and 2. Find out the factors of 3, that is 1 and 3. These are the 2 numbers which divides 3. Now, after this, using rational root theorem, one can conclude that 1 by 1, 1 by 2 3 by 1, 3 by 2, and negative of all the 4. That is negative 1, negative half, negative 3, and negative 3 by 2. These are the only 8 possibilities or 8 numbers which can be the roots of this particular polynomial.